My name is Magnus Hagander. I'm here to talk to you about Postgres 9.5. I'm a Postgres core team member and one of the committers who supposedly, writes on the code. Don't do as much of that as I'd like to, but at least I have the ability. I also do a lot of work for Postgres Europe, which is the non-profit that handles basically all the community Postgres work around Europe. When I'm not working on Postgres, I also have to do something to make money so that I can live. I work for a company called Redpill Linpro. We're an open source services company in the Scandinavian region. I'm based out of Stockholm in Sweden myself, where I work in what we call the infrastructure services department, where, well, basically I do Postgres work. At least I do primarily Postgres work. Where we do it's a mix of trainings, and we do 24/7 support like many others. General consulting services, lots of architecture works, and things like that. Anyway, we're here to talk about Postgres 9.5. So who in here is already using Postgres 9.5? Oh, come on, this is boring. Okay, one. In production. Okay. 9.4. Okay, that's good, so we're reasonable. Let's keep on that whole sort of show of hands things. How many of you guys regularly read Planet Postgres? The planet.postgres.org site. Wow, only 3 people in the room. I would suggest the rest of you start doing that. It's an excellent resource. In fact, we have a lot of people who are, it's a blog aggregator for Postgres, I should say, that first you know what it is. We have a number of people who do a good job at whenever a new feature is committed to Postgres, usually within a couple of days, somebody will have a blog post up detailing how it works, showing some example of how it can be used and things like that. So it's an excellent way to keep track of what's happening during the development and to get some more insight into the features than what I can possibly cover in a 45-minute talk with proper examples and all those things. So yeah, if you're not reading it already, I would strongly advise you to go look at the planet.postgres.org site. It has a lot of very, very good resources. Okay, so Postgres 9.5. Started its life in June 2014, so it's been around for a while. That's when the Postgres project branched off 9.4 in our Git repository. So basically how we do development is 9.5 was then continued the development on master, and at the time the branch for 9.4 was stabilized to become the 9.4 release. So during an overlapping period, we'd be working on both 9.5 and on 9.4. Then 9.4 was released about a year ago, early December last year. And since then, all development work has been on 9.5. The Postgres development cycle uses something that we call commit fests. It's one of those, well, everybody has to have an iterative method of doing development, and we just have our own name for it. Everyone should have their own. But the general idea is that we work for a month writing patches, writing code, and then we work for a month reviewing and committing those, which is the part that we call the commit fest. Now, we should all admit that this just didn't work this time because we were basically doing both things continuously the whole time. It worked for previous versions, but we've reached a point where it didn't really work, and we're looking into finding ways to fix that process. But we still have the basic schedule, which is we had 5 of these commit fests throughout the year to get in features. And then we had beta versions and beta versions, with one coming out just a week ago or so, which is beta 2. Beta 1 came out in, if I'm not mistaken, late September, something like that. So there's been quite a long time in between them. Surprisingly few fixes in beta 2 versus beta 1, which hopefully means that the product is quite stable at this point. It might also mean that there's not enough of you guys doing testing on it. So please help us out with that. Beta 2 is out. Packages are available for all the major platforms. So if you're using apt or yum or something, it's in the repositories. If you're using the graphical Windows installer, beta versions are available to download. We really need your help. We do need help to do code review, but we also need help to just take the beta version, put your workload on it, and see how it works, right? Did it get better? Did it get worse, right? If it got worse, it really helps if you tell us that now so that we can fix it before the release. It makes everything better. If you have a good testing suite for your own application, which I'm sure you all have, right? Because we all have that. then please take that, put that on top of Postgres 9.5 Beta 2, just run it and see that it works. And we're interested in both feedback saying that it works and feedback saying that it doesn't work, in which case it's so much easier to fix any issues before we go out with the actual production release than to try to do it afterwards. We'll still try to fix it afterwards, but if it's a behavior change of certain cases, maybe we can't fix it afterwards. Maybe it's you're actually relying on an undocumented behavior of Postgres that changed. Fine, but maybe it's as simple as we need to put that in our release notes for the next version so that others don't fall into the same trap. So please help us out with this testing. The more eyes we get on it, the better. And of course, if you are a C developer and if you're comfortable reviewing the actual code, we wouldn't mind help with that as well. But once we've reached this beta stage, it's really more about getting people to run it and to see what broke. Because there's always something that breaks. That's just how it works. So the current status, which was true as of last night, and I don't think anything has been committed to the beta version since then, is these are the differences if I compare to the 9.4 release. So we got about 2,700 files modified, 250,000 insertions, 250,000 deletions. So the actual code base didn't grow that much. It just moved around. These are almost double the numbers of 9.4. And we all know that lines of code is the best way to measure developer productivity, right? So this must mean that 9.5 is going to be twice as good as 9.4. Or, well, maybe not. But it does show there's a lot of things that are going on. There are a lot of things into Postgres. And in every version, 9.4 actually with about half these numbers was unusually low. And that doesn't mean that there weren't a lot of exciting things in 9.4. But there are definitely many, many exciting things coming in 9.5. So what I'll try to do is sort of split this up into 3 sections, which is really hard, but it's easier to get some sort of a split up. I've split it into sort of developer and SQL features, DBA and administration, and then of course everybody's interested in performance, right? So we'll put performance as its own step. And we'll start with the topic of developer and SQL features. So this is for those of you who are building applications against Postgres, not for the people who are actually building Postgres. They'll get to go to a different conference to learn about that. But SQL exposed or SQL layer features, there are a number of small things. Like this is one of my own favorites. It's one of those, I've run into it so many times and I just keep forgetting that we couldn't do it, so I'm really glad we can do it now. You can now do a multi-column subselect update. So if you do an update a table and set it to the result of a subselect, in prior versions you had to duplicate this subselect once for each column that you wanted to update, which was both horribly inefficient to write and quite inefficient to run. And there were some ugly hacks that you could do around it with like self-joining into CTEs and things like that, but they were really ugly hacks. Now you can just return multiple columns from your subselect and just do the update directly on the multiple columns. Obviously, it has to be the same number of columns in the subselect as in the query. Otherwise, you will get a similar error to the one you got before, which is, this subquery is returning the wrong number of columns. But it's one of those very small things that can have a big effect on your code base if you're interested. Another one is we've extended the generate series function. So first of all, who in here knows about the generate series function already? Okay, the rest of you need to go learn about the generate series function. It's really, really useful. It is a very trivial function. Basically, you call it, like in the example here, you say select star from generate series. This will generate a series starting at 0, going to 1 at an increment of 0.1. We'll just generate those numbers. And that's what generate series does. Oh no, generate series, so prior to 9.5, generate series would do integers and timestamps. Now it also does decimals, so numeric, but it's still just numbers. But even so, just being able to use it, for example, I've run into far too many times, I'm now looking at clients, I've seen clients who have a table with every date of a year, just so that they can join with it. Or a table with every day of the week, just the numbers 0 to 6 or 1 to 7. Like, don't do that. This is where you definitely want to use something like generate series. And with this new version, you're now able to also do it on decimal numbers. So it's an incremental improvement of a really, really useful feature. I think generate series has been around in Postgres for 10 years now, but I still coming, in most cases, I think this was actually more people than usual who had used generate series, or at least knew about it. But depending on where you go, a lot of people don't know about it, because obviously that's a Postgres extension. It's not something that's a standard feature. We have a new keyword for our selects, so you can do selects in even more different ways. You may remember we have a select where you could say no wait. If you do a select for update, Postgres will lock the row as if it was an update, right? If you said select for update no wait, if somebody else had locked the row or the rows that you were looking at, Postgres will give you an error. Like in the top example here, where we're trying to read from the table, someone else has it, it says error could not obtain lock, and it dies. In 9.5, you can also say select something for update skip locked, and it will just take any row in the table that somebody else has locked, we'll just skip it. Now, normally that's not the solution you want in your database, right? If I said I want to select everything from my table, I don't want it to randomly skip rows. But there is at least one really good use case for this, which is if you have like work queue tables, where what you'll typically do is you'll have a bunch of workers who are sort of picking things off the queue, and they'll do something like select star, well, you can list the column names, but select star from my table, some order by timestamp limit 1, because you're taking the first thing off the queue. And if you then just add a skip locked, suddenly you get concurrency in this operation. Because the first worker will grab the first row and keep the lock since we did select for update. If the second worker comes in, it'll skip that row and go to the next one. And just work throughout the table. Whereas previously, yeah, you would do the no wait, and then we'd have to, let me try it with offset 1. Oh, no, it got an error, let's try it with offset 2. And then the table changes underneath you and weird things happen. Or you just had to implement the locking separately and not hold the lock on the table across what you're doing. Yes? So the lock itself comes from the select for update, right? Which gets you an exclusive lock on the row. So it would make no sense to actually do exactly what I'm doing in the example here, which is select the whole table this way. That would be just strange. But combining it with a where clause or with a limit, yeah, it only makes sense if you have the select for update. Otherwise, MVCC would let you see the row without the lock anyway. Yeah, okay. So yeah, truncate table will take a DDL lock or an access exclusive lock on the table, which this will not help you with that. So truncate is considered a DDL operation. So it locks everything out. This goes against other select for updates and against people doing updates natively on the table. So that's a couple of fairly small features. Then we have a number of really large features that are exposed at the SQL level. The first one I'd like to highlight is row level security, which allows us to apply access policies on a per row basis. So we already have things like table permissions and column permissions, right, and database and schema permissions. This allows us to limit the access to individual rows in a table by basically applying what I'd like to call it's a mandatory where clause. So whenever someone selects, we'll just add an extra where clause to what they're doing to make sure that they can only see specific rows. For example, a particular customer should only see rows belonging to that customer. And we can put that at the database level. Of course, regular ACLs still apply, so you still need permissions on the table or on the column as well. This is just an extra way of limiting it. And as with most things, super users and owners in Postgres always bypass. We also have a new attribute you can set on the role, which is bypass RLS, which will just, for that one role, we just don't apply any row level security policies. That's just one of those, alter role something with bypass RLS, and it'll be able to bypass all of the RLS functions. Yes? So this one applies on the row, but you can then also combine it with a column permission but that's the existing column level permission. But you can combine it with this to lock it down further, yes? RLS is not enabled by default. You need to turn it on your tables by saying alter table, enable row level security. Until you do that, it does nothing. And what you do then is you create a policy, or you can have more than one policy, but in the example here, it's create a policy. So this is just simply, I have a simple table called companies. I say create a policy, companies manager on this table for all, which means it's for all operations on this table. To public, so the public role applies to everyone, and we'll say using manager equals current user. That means that me as a user, I'm able to see any rows where I am the manager and nothing else. And just as an example, a simple PSQL session for this one where you have, I'm logged in as the super user, as you can see from the PSQL prompt. I can get the 3 values back. I reconnect as the user test, run exactly the same query, and 2 of the rows just disappear. And the thing we can do with this is you can put these policies on any regular expression. And yes, I realize that's it's not a regexp. Okay, it's not that. It's sort of anything that you can write as an expression in Postgres, as long as it doesn't have aggregates, basically. You can create that as your row-level security policies. You can have multiple policies on the same table, in which case the results are ORed, so as long as there is a policy that lets you in, you get in. One thing to remember, it does not affect your cascading RI. So if you have foreign keys, what it will do with foreign keys is it can block you. So it can get you some interesting scenarios where row-level security doesn't let you see the row in the other table, but a foreign key lets you know that it exists. Like you can end up in such scenarios. But if you have an on-delete update or on delete cascade, something like that, it will not apply to that. So those will still follow the foreign keys and update or delete the row on the other end, even if you don't have RLS permissions on the other row. Yes? I mean, yeah, of course, the way that it works through the foreign keys, yes, it does have some security implications. It's something that, if you're using this to, tightly lock down classified data or something, you need to carefully investigate exactly what that means. But there are things in like how just the relational model works that makes it impossible to not leak some of that information. So you just need to be aware of exactly what kind of information is leaked. But yeah, so you can put really, really complicated things in there. I tried this one just to be allowed to file a bug report to Stephen, who wrote this, to show me it didn't work, but it turns out it worked. So you can put a recursive query in the RLS policy. In this case, it's the classical, I am the manager, or I am the manager of someone who is the manager, or I am the manager of someone, and you get the whole thing. And that runs just fine. Now, the thing to remember, actually the implementation of this is also very close to being a mandatory where clause. So if you put a really expensive check in your RLS policy, all your queries on this table will now become very expensive because they have to run this check. And more or less, it just puts this on as a where clause at the end of your query. It's obviously not quite that simple, but the implications are the same. So in this case, we end up running a recursive query a lot of times to verify that I'm allowed to see the rows. Again, if it's something that we need to do, then obviously we should do this. But we need to be aware of that there can be performance implications if we make these policies complicated. Yes?
I have a question on using this like in a typical web application where you have numbers of users like in some table somewhere. This is all on the level of Postgres users.
Yeah, this is on the level of, well, that depends. If you look at this one, I'm using current user there, right? You could, for example, set a session variable and use a session variable. Like it's anything that, as long as you can form it as an expression in SQL, then you could use it. But you'd need to, if you're mapping it to web users, yeah, you'd need somehow to be able to tell the database which web user is currently running. But in a way, it's a way to sort of apply. You can do exactly the same thing today by just adding this where clause to every single query that you run. But if you put the policy on the table, you don't have to remember to add that where clause. But any parameter that goes in there, you still need to be able to feed them to the system. Okay, so the next larger SQL level feature is what we call insert on conflict, commonly referred to as UPSERT. which is, UPSERT is one of those things that everyone wants to do and nobody's really managed to make a really successful implementation of, because it turned out to be a lot harder than it looks. It's similar to what the SQL standard calls merge, which is also similar to UPSERT, but they're slightly different. In particular, the SQL standard merge just punts on the whole idea of atomicity and isolation and things like that. It surprised me greatly when I learned that Oracle has merge and it's not atomic. That's not what I expected from Oracle. So Postgres does not, the implementation in Postgres is not doesn't do merge exactly the way that the SQL standard intends you to do merge. For that reason, it's not called merge, because we reserve the right to maybe implement merge per the SQL standard at some point in the future. Just like it does not have the same semantics as some of the implementations in, for example, MySQL. So we're not copying their syntax either, because it doesn't work exactly the same way. Now, in my opinion, and in a lot of others, the Postgres one actually works the way you want it to. It uses a technique called speculative insertions. I'm sure you can get a lot more details later. Actually, I think Peter Gagan has a talk, it might even be in this room later today, talking about UPSERT. Who's the guy who wrote this? So he can probably tell you a lot more about the technology underneath it. Yeah. So, but it does. In the end, it does what you want, right? It lets you control what happens when you do an insert and there is a conflict on a unique key. So in its simplest form, I'm trying to insert. I have a simple table. ID here is my primary key. I say an insert into this test table, ID, t, values, to and foobar. Then I say on conflict, do nothing. So that means today, if I did this insert and there was already a row with key value 2, I would get an error. With this statement, we suppress that error. And we just say, no, if it was there, it was there. We don't really care about what it is, but number 2 is already in there. There's no notification, there's nothing. It does exactly what it says, do nothing. Right. Of course, what you often want to do, and the part that's actually UPSERT, is if we instead say like this. So we still insert 2, foobar, and then we say on conflict of ID, which means we get a conflicting value for 2, update set t equals excluded.t. So that says if the key 2 didn't exist, we insert it. If the key 2 existed, we will update it with the value. And then we have this virtual table here called excluded, which will contain all the columns here for the rows where we had a conflict. So this is the basic UPSERT, right? It says I have a key and a value, or however complicated the row, and I'm saying insert it if it's not there. If it's there, update all the fields to have the same value that you would have inserted if the row was new. So that's the simple UPSERT case. But we can do more advanced things using this on conflict syntax. We can, for example, do something similar to this, where we say, so I've got a new table here that's a counters. It's doing some count based on a URL. We say insert into counters, values, the URL, 1, on conflict URL. So if the URL is conflicting, we do update set num equals counters.num plus excluded.num. So we're not taking the number that we try to insert, storing it in the table. We're taking the number and we're adding it to the value that's already in the table in this case. And of course, that doesn't have to be a 1. That could be any number, and we'll just add it to what's in there. And the big thing about this, of course, is this is safe even if you have 100 concurrent users updating and inserting on the same row, which is where many other implementations of UPSERT just don't work. So it lets you do, and again, you can put very complex expressions if you want in the update statement. And of course, you can treat, it doesn't have to be just the num. You can have many columns up here and do different things with all those columns. So you can say, if there is a conflict, I only care about 3 fields. The other ones are going to stay at whatever they were before, for example. You can update things last modified. You can have a specific column tracking when did a conflict last happen and just update that one. You can do any one of those. Well, this is different from rules in that it does, if you do something with the rule, you can change the insert, but you can't do it dynamically. And what we've previously done for this is things like a little loop in a PGSQL function that tried one and then the other, and then you caught an exception and tried again. And I mean, this is obviously implemented at a much lower layer than that, so it'll be much, much faster than that. So you can get rid of all those loops. Well, if they were doing just this. There are other things that might still require custom coding, but for the common case, which really is the insert it, if it's already there, do an update instead. This will replace that entire procedure, so with just one line. Yes? Sorry, update is basically an insert? Well, okay, so you still, inside of Postgres, yes, your update will write the new version of the row. It'll, because of the MVCC, that is still there. Because we need that for the other sessions to be able to read the old version of the row while this is running. So the difference is when you do an update, you get two versions of the same row, whereas this is actually a separate row. So it'll end up being, if it hits the insert branch, it'll be a completely new row. If it hits the update branch, it'll be a new version of the existing row. And you being able to do that without making a big lock is the big win. Yeah. The third larger SQL level feature that I'd like to highlight is that we have support for grouping sets. Now this is commonly, what most people think of when they think grouping sets is the ability to do cube and roll-up queries. Postgres does also have the fully generic grouping sets. Whereas cube and roll-ups are just the two most common subsets of these. And in fairness, they're the main things that I've ever seen. These are sometimes referred to as super aggregates. They're sort of an aggregate over an aggregate as part of a group. Made perfect sense, right? We can use them for things like partial sums across multiple groups and things like that. So the easiest case, the roll-up. Okay. If you just did, in this case, we have something, select department and count from employees. If we just said group by department, you'd get a number for each department and the count for each department, right? And if we instead say group by roll-up department, we get the count for each department, and we get this field down here where we get a null, and the count, which is the sum of those two. If we do this just across a single group, I mean, yeah, you could probably make that count pretty easily yourself in the application, right? But it becomes more interesting when we do this across multiple columns. So in this other, we're doing something, this is clearly payout, so we say select department and name and count star and sum payout from payouts, and we do a group by roll-up of 2 columns. So what we're now getting is, for each department, we get the count and the sum for that department, and the count and the sum for that department, because this value here is coming back as null. And then finally, we get the count and the sum for the whole query as well. And you can, of course, you can do that at a 20-level group by if you want. There is a function you can get, because this one comes back as null. There is also a function that's just called grouping. You can call on that. That will return true or false, whether it's because of the grouping. If you have null values in the actual table, you would get 2 rows of null, one being the sum and one being the actual null value. So you can get that out by the function of grouping. This is something that we had in a lot of the other big databases like Oracle or SQL Server. Those guys have had this for a while. I've seen some really interesting solutions to this when porting things to Postgres, like really, really big trees of union all. Not very pretty and not very fast. So this will definitely make this style queries much, much easier. And yes, of course, you can do that summing in the application, but it'll be much more efficient to do this down in the database where we have the full performance. Oh yeah, I mean, this is just a generic result set, so you can sort it by anything you want.
So I can get sources by the sum.
Yeah, absolutely. You can sort it by this value, for example. Yeah.
No, the count on the top.
Or yeah, you can sort it. Yeah. So because again, you can put the expression, if you want to sort it by this fact, you can just do an order by grouping name. which would then return true for those and false for everything else, and do a multi-column order by to get those. So you can get a lot of data back out. Yeah, you can do it in any order. So this is the roll-up one. The cube is really more of, then you get, the cube gives you everything, right? So now you would get a sum for each name if you added the cube. Now for a query like this, that would make no sense, right? But there are certainly cases. So a roll-up will get you the sort of sideways, whereas a cube would get you the full mesh of every possible sum that you can get from your result set. So if you do a cube on a 20-column group by, you get a lot of rows back. And then the actual sort of generic grouping sets, you can specify exactly which ones you want it on. I find roll-up being really the 95% case, and then cube is going to be the next 4.5%. I've very seldom run into a need to actually use the full grouping flexibility. But it's there if you need it. Cube is very common for OLAP analysis, yeah, because you just sort of explode everything out so you can look through it. Okay, so let's leave the SQL level features for a while and look at some of them that are more at the DBA and more at the administration side of things. Again, let's start with something simple. We have a nice new configuration parameter called cluster name. If you run multiple instances or multiple clusters on the same machine, it can be a lifesaver. It's very simple. The only thing it does is it adds it right here to the process title of every process. And suddenly you know which cluster each process belongs to. That's really all it does. But that's very useful if you have many instances. Like, it's really useful for those of us who build things on Postgres who might have 10 different instances running at the same time on their laptop. You probably don't have that on most of your production systems. But having multiple instances on developer systems or testing systems or such is not exactly uncommon. So it's a very simple one. Is anyone in here today using the FDW, the foreign data wrapper for Postgres, to access remote databases? Okay, a couple of you. One of the things you may have noticed is that in order to access remote tables, you have to run create table statements for all of them. If you have a schema with 100 tables, you have to manually create each one of those. What we're adding in 9.5 is the ability to say import foreign schema. So you can just say, here, import foreign schema, test schema from this server that we've defined into my local schema. And Postgres will go out and enumerate all the tables on the other side and create foreign tables matching all of them. This will work actually for any FDW that adds support for it. I don't know if there's any other than Postgres that does it so far. But in some cases it might not make sense, but it makes it easier to work with. This will only snapshot it. So if I go out and say import the foreign schema now, it'll copy whatever tables are there now. If you then go and create another table on the other server, you'll have to go import that schema again or fetch that table again. We don't sort of keep track of that schema live. It's not very difficult to write a little script that would do that, but you get to write that script. We don't provide that one for you. Another enhancement of our foreign tables is that a foreign table can now take part in an inheritance tree, which is one of those things. I think a lot of people who just followed like the commit messages or anything are like, okay, so what? Foreign tables can take part of inheritance trees. Why do I care? The thing in Postgres is we use inheritance tree to implement partitioning. It's not the best ever implementation of partitioning, but one advantage is that once this works, you can actually end up using this for sharding in a simplistic way. It needs to be enhanced to be really useful, but you can say, I have this table with 10 partitions. This partition over here actually lives on a different Postgres server over there. And this partition over here lives in Oracle over here. It doesn't all have to be Postgres foreign data wrappers. So you can have different partitions of the same table living in different databases. Which can be used for sharding. Now there are a lot of cases where we're unable to push down the really efficient queries across these. So it's not at this point any sort of magical solution that means we've solved the sharding problem transparently and you'll never have a problem with that again. But it's an interesting piece of foundation that today works in the simple case. And hopefully we can get it to working in the much more advanced cases as well sometime in the future. there's a lot of people who are working on exactly that. We'll see how long it takes them. If you are using unlogged tables, you're now able to switch a table between logged and unlogged without dropping and recreating it by simply saying alter table set unlogged or alter table set logged. When you do this, when you change a table from unlogged to logged, Postgres will write that entire table to the transaction log, because suddenly it needs to show up on replicas, for example. So that can take a long time. You should be aware of that. Whereas, of course, switching from logged to unlogged is a very cheap operation because it just sets a flag that you don't need to care about this table anymore. So it's a much cheaper operation. But going to logged does work, but if the table is large, you will get a very large burst of traffic to your transaction log, and it might take a long time for that command to actually complete, depending on exactly how large it is. If it's better to drop and create, well, if the table has data in it, and you want to turn it into logged, you drop it and recreate it, you still have to load the data. So it doesn't actually, I mean, if you want the table to go from unlogged to logged and it has data, there's nothing we can do other than to log that data. Otherwise, it wouldn't make it over to your replica, for example, and it wouldn't make it into your PITR backups. So the data needs to get written there. When you set it to unlogged, no, it does not drop the table. It's, and on the replica, an unlogged table is there, but it's empty. So actually, I haven't tested that, but I'm pretty sure that what would happen is it would truncate it on the replica when that happens. If you are today using alter system set to configure your system, is anyone actually using alter system set? Yeah, I'm not entirely surprised. It's not a very common feature. If you do that, you now have the ability to do alter system reset. Right? Resets the configuration variable back to whatever happened to be in postgres.conf. If there was nothing in postgres.conf, it goes back to the default value. What it basically does is it goes into this postgres.auto.conf, which is where alter system set parameters go, and it just removes the value. You still have to remember to do the select pg reload conf or do a pgctl reload after you've done that, just as you did with alter system set. You have the same sort of issues if you change something that requires a server restart. Weird things can happen. But if you are using it, it's a way to go back. We've added the ability to do commit timestamp tracking. What it basically means is, well, we can track exactly the timestamp of every single commit that's made on your system. You set the parameter track commit timestamp to on, and we'll do that. You'll get the ability to do, for example, in the case here, select xmin, but in particular pg exact commit timestamp, and give it an XID. It'll tell you when was this XID committed. If you use this in combination with xmin, this is when was this row written to the database. Or when did someone last commit the transaction. This is not turned on by default because there is definitely some overhead. There's a bunch of data to keep track of. There's more data to keep that you need. But this is something that's required for some of the logical replication, in particular for the bidirectional logical replication solution, needs commit timestamps. If you're using that, it's an overhead you're willing to pay, obviously. You can use it standalone from that. Exactly how much overhead is going to depend completely on your query patterns, so you'll just have to turn it on and measure it. That's basically it. Question? Well, the XIDs are not always increasing if you look at overlapping transactions. So yeah, but the timestamp will be whenever it happened. I'm sure weird things can happen if you change the time of your server, but don't do that. There's really no, if we're tracking timestamps and you change what the time is, there's not much we can do about that. Yes? The last transaction that acted on a row, that will be this, well, that's the xmin column, right? As long as the row still exists. But it's the last version that you can see from your session. If there's another running transaction that updated it after you, you can't see that. So there's no way to see that without doing like low-level page analysis. but as seen from your transactions viewpoint, xmin will tell you who updated or created that row.
So that example, xmin is kind of a virtual column.
Yes. I'm sure you've all at some point configured checkpoint segments in your Postgres server. It's gone. No more checkpoint segments. Instead, we've replaced it with two parameters, min val size and max val size. They're no longer in this annoying unit of files of 16 megabytes. You now just specify them in megabytes or gigabytes. And what Postgres will do, it'll dynamically try to auto-tune its checkpoints to happen somewhere between these. The default values have also been increased drastically. The default value before was 3, right? So 48 megs. The new values are minimum size 80 megabytes and maximum size 1 gigabyte, or the new Postgres defaults. Now, if you are actually space constrained enough that 1 gigabyte of Xlog is too much for you, then you need to lower that default. But most people for larger databases have increased their checkpoint segments up to these numbers anyway. It'll also now only actually consume this space when needed. It won't, if it's set to 80 to 1 gigabyte, and if you ever needed 1 gigabyte, it won't allocate 1 gigabyte. But if you actually did need it, it'll go up there. So in general, default's much better. Basic workings are still the same. Recovery target action has replaced post at recovery target. In your recovery.conf, when you're doing a restore, you now specify recovery target action to be either pause, promote, or shutdown. Pause is the old pause at recovery target true. Promote is the old pause at recovery target false. And shutdown will make the system, when it hits your defined recovery target, it shuts the system down. In not going up, not going down. For example, if you want to clone it at that point or something like that. But your old pause at recovery target is just gone. Useful tool added to the system, PG Rewind, allows you to repoint an old master if you do a replication switchover. You'll be able to reuse your old master as a standby to the other one without rebuilding it from scratch. It requires a few other things. It needs you to enable logging of hint bits. But once you've done that, you'll be able to do the repointing. It's still an offline operation to do the repoint, but it's something that you can do. We have some more monitoring. We have a new view called PGStat SSL that lets you show information about your SSL connections in the system. Same information as you could previously see through SSL info, but now being a super user, you can see it for everyone in the system, not just for yourself. So you can see if people are connecting, what encryption they're using, if they're using a client certificate, and all those things. There has also been further enhancements to PGStat statements. Who is not using PGStat statements today? Wow, everyone in here is using PGStat statements. Excellent. We have now tracked max, min, mean, and standard deviation for execution times on all the queries that you have in PGStat statements. Make it even more useful. But yeah, I'm glad that everyone's using it. It really gives you an insight that we did not have before. Who in here has ever used PGXlog dump? I'm so sorry for you. So PGXlog dump has previously basically been a tool that's only useful if you're screwed. Something went really wrong. Now there is a new parameter. You can run PGXlog dump with --stats, and it'll actually, you point it to a number of your transaction log files, and it'll tell you what's in there. So it'll tell you what is it that's actually causing a lot of transaction log to happen in your system. So it's another way to see what's actually going on. Now, of course, you can still use all the low-level things in PGXlog dump, which I really hope you don't ever have to use them. At least not on a production database, because once you get there, you know you're in trouble already. Okay, I've only got a few minutes left. Let me focus on the things that everybody wants, right? Whether you're on the developer side or on the admin side, everybody wants more performance. We have a new type of indexes in Postgres 9.5 called BRIN indexes. Some of you may know of these as min-max, which was what they were initially called. BRIN means block range index. And min and max is going to be the most common use case for them, but it does support other op classes. The idea behind these are very good data warehousing indexes because they're for large amounts of data because the index is very, very small. On a typical index, your typical binary tree index, if you index a column, every value will get put somewhere in the index, right? You have your primary key index, every ID value will be somewhere in the index. It'll just be in a tree structure. For a BRIN index, instead, we pick a block range. So a range of blocks, the default being 128 blocks of 8K each. And then we store the highest and the lowest value that appears somewhere in this block range. So for 128 times 8K, we only store 2 values. This means that the index is going to be tiny. And then when we query it, we'll go see, okay, I'm looking for this value, and we'll get back a block. The index will then only give us a block of 128 blocks of 8K, and we'll have to scan all of those to actually find it. So that the downside is it's a little bit more to search for. But it's, in particular, if you have a naturally ordered table, say that you have a timestamp column in a log table, the BRIN index is going to be really efficient because you're going to be able to pick out of your multi-terabyte table, you can pick out a single block of 128 times 8K and only scan that, which can make it really, really fast. You create it, it's just like any other index. You say create index and you say using BRIN and tell it which to go. And as long as there is a BRIN operator for it, it will just work. Index scans will always have a bitmap index scan on the BRIN index and then a bitmap heap scan on the table. That's because this part up here, the bitmap heap scan, is where we go rescan these 128 blocks because we have to read them in the table. There will obviously no way to do like an index-only scan since we only store the top and bottom value. And you can also specify this pages per range as a parameter on the index to say how big. The bigger the number you get, the smaller the index will be. But also the more data you will have to read to actually get to that data. So if you have large tables, like if your table is small, like I don't know, only 10 gigs or something, this is probably not going to be that interesting. But if your table starts approaching hundreds of gigabytes or terabytes, this can be a really big performance enhancement. And if you're taking a lot of updates, it's an index that is much cheaper to maintain as well. Yes?
That's, if you're really unlucky and the table at first contains the whole range of values, and then you keep inserting values that fall into the middle of the range, would that require basically
Then the BRIN index is just not going to work for you. Yeah, no, that's where the part is. Like you need some sort of like natural order in the table for it to be efficient. Yeah, or in a lot of cases it might just be the surrogate primary key for a lot of people. But that requires that you're actually querying on the surrogate primary key, of course. No, yeah, the worst case is basically degrading to a sequential scan, which is probably what you had before. But you're not going to get the big gain on it. There's been a bunch of benchmarking done, but I think we're still in the position we don't have benchmarks of actual customer applications or actual production applications. You can do a lot of benchmarks that shows how brilliantly awesome it is. I mean, everyone can do that. It'll be interesting to see what it can do to actual, real world applications. If you hit the perfect case for BRIN, it can be, many, many orders of magnitude faster. In particular, that updates are very cheap. We have an update to the code for the GIN pending list, which is where we store sort of temporary updates in our GIN indexes. It is now configurable on a per index basis. If you don't know what it is, I don't have time to go into it in detail, sorry. But previously it was slaved of workmem, which is completely incorrect. You can now configure it globally or per index. This is where we store changes to GIN before they get merged back into the table. Our GIST indexes now support index-only scans. Very nice, it's completely transparent, things just run faster. I like those changes. We have the ability to compress the transaction log. We will only compress the full page images, but the idea here is you trade I/O for CPU. In particular, you can get lower volumes of data across your application, lower volumes of data into your archives. It also came with a new transaction log format and CRC algorithm, but that's something that you as a user just don't have to care about. But it's made a bunch of other things easier. In the targeted things that are just nice and working for you, we have some A lot of enhancement to the sorting that's done. We have abbreviated keys for sorting of text and numeric. We have pre-check for equality because comparing memory is faster than comparing strings, and a few things like that. And these are all basically things you can just assume everything you do that uses sorting is going to be faster. And you don't have to do anything to make it do that. It'll just be faster. It'll be much faster or a little bit faster depending on what kind of things you're doing. But you can sort, in particular, if you have large amounts of data that you're sorting, the gains can be really big. And it's entirely transparent. We also have a bunch of changes. We have an internal atomics API, and lots of our logs have been rewritten on top of this. We have a number of operations like with triggers and foreign keys that are now lockless, so you can do more things without blocking other people out of your database. You can scale more things across many, many cores. Again, nothing you need to do other than upgrade to get access to all that. Of course, wherever you are, there's, sorry, got a question on that? The locking thing about foreign keys is it's about alter table and foreign keys. So if you'll be able to, for example, drop a foreign key without taking a DDL lock on the table. No new command. Same new command, same old command just doesn't require locking anymore. Yeah, so it's transparent. Of course, there's always more, right? And I don't have that much time. There's always lots and lots of smaller fixes, performance enhancements. Luckily, there's not that many contributors in the room right now. I think I see only one, and I've mentioned at least one of his features, so he should be happy. So I haven't skipped any one of you. There's no way to mention them all. There are hundreds of changes, obviously. So we do, again, we'd like your help to test them out. We'd like your feedback on both the new and the old features. Let me just do one run of those before I finish. Of the ones that we've talked about here, who thinks that the UPSERT or the insert on conflicts the most important feature in 9.5? Okay, what about grouping sets? Interesting, no one. That's the first, or one. One or so. Row level security. Okay, foreign table inheritance. Yeah. BRIN indexes. Okay, it's a bunch. So those of you who didn't put that out, put your hand up for that. What's the most important feature? Foreign key locking? Yeah. So good. Anyone else? Yeah. Yeah. Alter to and from unlock. I find that really interesting because I've done this in a number of different places. And it's always a different feature that comes out on top. Well, not always, because I've done it more than this number of times. But it's really interesting where you are. You can tell, we're in Silicon Valley, right? Silicon Valley likes UPSERT. I've been to places where not a single person put their hand up on UPSERT. Surprises the hell out of me. But if you've got a group of people who are like, experienced DBAs who've been used to working with like Oracle systems, grouping sets usually comes out on top. And in certain groups of people, RLS comes out on top. So I think what that really says is, we got a feature for everyone. We got a great feature for everyone, and then, all the other features, you get them for free, right? So with that, I think I'm basically out of time. So thank you very much for showing up. I'll be around here all day. If you have any other questions on this or just generally about Postgres, just catch me in the hallway or at lunch or something like that. So thank you very much for showing up.